So logs and exponentials are the last two types of functions that we study derivatives for. Okay, we will also do derivatives for relations, stuff that's not functions. Okay, and that's next week. Okay, so logs and exponentials are functions. They're pretty straightforward, and I think you'll probably catch on pretty quick. So an exponential, what would an exponential be? Give me an example.
X squared.
Yeah.
No.
No?
X squared is not an exponential.
Oh, you don't like a straight.
Okay, that's a polynomial. So, and that's why I asked that question. It's a misconception, okay? An exponential has an exponent
Oh, that's
variable.
like to the X. Yeah.
Exponent variable. This is an exponential. Okay,
That's what I meant, I'm just dyslexic.
that's not what you said. Thank you. All right, so know the difference there.
Did you start it?
It? It's on.
Yeah, it is, I got the number.
Okay. The question is, how would I derive that exponential? Because this is not a power rule problem anymore. Okay, we cannot power rule this. Okay, so write no power rule. That's the common mistake. It's not x 2 to the x minus 1.
Oh, why not?
Ask God. I don't know. It's just the way he made it.
Because Newton said so.
Yeah, right. So a derivative of this exponential it's really straightforward. Natural log 2, 2 to the x. That's the derivative of an exponential. Okay.
So it's the natural log of the constant.
Yeah. So natural log of the constant value, and then copy it. So it's just as easy as the power rule. You just have something else to memorize, right? So if we're going in general, we like to generalize things in mathematics. Okay, B is your base.
Hey, look, I still end up right.
Pretty strong smell too. Okay, so this is the generalization. B is a number greater than 0. Why is... let's write that down. B cannot be negative. Why?
Because
Say that louder. Yeah, natural log is not defined in negative numbers. Okay, so keep that in mind. All right. We can do chain rule problems with these, right? Yeah, the big letdown.
That's already changed those. Wait, don't mind where you He said with the pencil.
I suppose I will be a merciful teacher and wait.
What would double prime of that be? 2
Stop.
natural log?
How about we don't think about it?
It would be, natural log 2, 2 to the x.
Oh, okay.
So-
So you just keep adding natural log.
Pretty much. So it'd be natural log 2 squared. It would be 2 of them.
Yeah.
It's squared, yeah.
You just keep adding them.
Okay, moving on.
Right.
Let's derive a few of these with the chain rule. How about this one?
That's just
enough to give you
nightmares.
That gives you a nightmare?
All math gives me nightmares.
Oh, well.
Basing you on.
Your life must be full of the lack of sleep.
You have no idea it is.
I don't. Okay, f prime of x equals. Okay, so it's a chain rule, right? Outside function is still the exponential, right? So ln 4 to the 3x times derivative of the inside 3. This is the inside,
I'm cool with this.
so we derive the inside. See, copy,
Right.
derive.
Oh, okay.
So this is like with the E, how like the const.
It's the same concept, yeah.
Oh,
Same as sine, cosine, tangent with the chain rule, you know,
yeah.
you copy whatever's in the parentheses or the exponent, you just copy it. Right? So. Here's another one. See if you got it. Do that on your own.
Okay. Wait, is that 5?
5 to the x squared. It's just, it's an exponential, dude. No need for that.
Never seen it. So the exponent.
Gotcha.
Mr. Arthur lets his students cuss. It's proof.
Way to go, my
It's a good thing our principal's on time to listen to these, because I would be in trouble.
He'd be like, Arthur, let me have a chat.
I think I got it.
I made it too, but I'm not gonna say that because they don't make it. You should make Mason try.
Dude, I did right.
What about now? Actually, I'm actually really confident on it. I could.
Kyra,
Next time I got it. So,
So you better hurry.
G prime of x equals natural log 5 times
Don't drink
f
that.
to the x squared, not f, 5
Yeah,
x
there you go.
squared
You know what? Drink
times 2x.
Just tug all over.
you got it.
I didn't know what I was doing, but I did it right.
Okay.
From yesterday. And God knows how we got there.
Could you,
Okay.
It's not that like complicated, it's, I could see like forgetting this rule would happen. It's easy to forget.
could you do that still? Because I haven't, write the equation of the tangent line to g at x equals 1.
Yes.
Plug 1 into g of x, that's the slope.
I never did the.
Plug 1 into,
Okay, you misspoke.
You mean G prime of
or
X.
g prime.
Yes, now he's right. Okay, so continue to, this is a big thing, so you know, we're looking at plugging, evaluating g at 1 gives us 5. That's our point. And g prime at 1 gives us,
Zero.
What's the natural log of, natural log of 5 times 10?
stop it, ln 5 times 10.
I'm still why?
Because 2 times 5.
2 times 5.
Yeah.
Plug 1 in. I have lost my faith in you. Happy as a lark, disappointment. I'm just kidding. Yeah, plug 1 in, all right? So what's our equation?
Y minus 5 squared.
Oh, it's just 5.
16.09. Wait.
That times x
Wait, what?
minus
You
1.
can just write that? You can't just mix up the order.
Yeah, you can.
can.
Multiplication is commutative.
That's the word.
10 times 5 is the same as 5 times 10.
Yeah, but you can't.
Multiplication is, dude, seriously.
He's a math teacher. It's literally his job.
It's not my job to mess with your minds, it's my job to enhance your minds.
Blow your mind.
That is technically when you hand something.
Not really, but I can do that if I want to.
Wait, but wouldn't that, isn't that different than saying log natural 5 times
Stop
10
getting
times
excited.
x minus 1? Because then you.
No, same thing. These are multiplied.
Gleam in your eye.
Multiplication is commutative.
But like if you put the 10 at the end of the log 5 in the equation, I would immediately just spread the 10 to the.
You could do that too.
You can? Oh, okay.
Kyra,
Needs to feel.
Do you have a jingle for like that actually?
do I have a what?
Do you have a jingle for that formula? I can never remember.
This line slope.
Yeah,
Dude,
Like, oh.
you have a note card, right?
Yeah.
What?
Yeah, I have nothing.
Is it?
I think
I
that
don't know what to tell you. Moving on.
I-
Okay, natural log.
natural log.
This is a very popular function in calc, so we have to derive it.
Okay.
No, that's what you get.
And it's a very,
Just that into an exponential function.
Oh, 1 over x.
no, it's just, don't ask, well, you can ask me why, I'm gonna tell you I'm not gonna show you, because you need to be sheltered. Just trust that that is true.
Okay. That's about
The
right.
derivative of natural log x is 1 over x.
Okay. Okay.
Okay? Just let it go, man.
Yeah, tell us twice.
Thanks. Oh, man.
I start singing Beatles.
You wanna know what gives me nightmares?
Frozen.
Do you have a little daughter?
Poppy Disney soundtracks.
Ah.
Thanks, Frozen.
Did
Okay.
you say poppy?
Yeah,
Yeah,
pop,
Poppy
you know,
the
like
Trolls.
pop, pop.
Pop
Like
style
the music
music.
pop.
Oh.
YouTuber.
That's what I was thinking, like, yeah, like.
All right, chain roll with natural logs.
I hate.
Moving on.
Moving on.
Chain roll with the natural log.
You take the outside.
What's the outside function, Kyra?
Log.
Yeah, so
Natural log.
1 over x squared times
Times 2x.
2x. So again, derivative is 1 over x, put that there, copy it, and derive. Okay?
Where'd that x squared come from for the outside?
It's right there. You have to copy the inside. Where the x usually goes is where you copy
So if
the
that was like
inside.
x squared plus 2, the bottom would be x squared plus 2.
Yep. Okay, can you simplify that?
No. Yeah.
Yeah.
I hope so.
2x over x.
Because it's 2x over x squared.
So it'd be 2 over x.
2 over
Oh, yes it is.
There we go.
All right, so chain rules with natural logs, right?
Right.
Here. Lastly, let's look at non-natural log logs.
Non-natural log.
Yeah, it's like
I didn't know there was an echo in here.
Artificial log.
it's like building your deck out of redwood versus Trex. You have no idea what it
Can
is.
we call it artificial log?
Trex is a fake material. It's synthetic.
I like that recycled.
What?
Redwood is real log. Trex is a fake log. You know, we're doing like natural logs versus non-natural logs. Do you draw the
Yeah,
connection?
what chapter,
Dude,
what
seriously?
material?
I'm not making any more industrial arts jokes.
No, I got what you were saying. It's just.
I appreciate them.
I can't make those jokes in woodshop either because none of them are in calculus. Because Montaigne skipped out on me this year.
Gosh,
There you
Montaigne.
go,
You
Montaigne.
make jokes.
All right, to do these, the best way to tackle these is to change the base.
Change what now?
Oh.
Wait, but we like base 10.
We like natural log better in calculus. We're going to change it to a natural log problem.
Okay.
All right, so g of x, does anybody remember change of base from last year?
Absolutely not.
Okay. It's,
Yeah.
Ow.
where's that? Oh, it's gone now.
Thing.
Moving on, change of base. Put that on top with natural log and put that on bottom with natural log.
Okay.
Now it looks.
Because you're changing to a base e so that we can do the derivative e, all right? So can you derive that now?
Yes.
Yes, you can. No, it's not a quotient rule. This is a, hey, oh, stop. This is a constant.
Oh, so that's 0.
Huh?
Okay, so you're basically, this is what you have. Okay, that's a number. We're just gonna leave it alone. It's a constant, right? Times something?
Okay.
It's like if I asked you to derive 3x squared, this is a constant, right? So the derivative is 6x. we left the 3 there and multiplied it, right?
Right.
You leave that there, it's a constant. It's just a number. Okay, so g prime of x is 1 over natural log 10 times
Log natural x.
where's the 1? The derivative of that.
1 over x.
Keep the constant, derive natural log x. That's it. Okay, because they're multiplied, right? We keep the constant there.
So then you could just simplify that, right, for 1 over log natural 10x, right?
You could do 1 over, this is how it's usually written.
Okay.
Just to make sure that the x and the 10 are not in there together,
Okay.
we put it out front,
Alright.
just to make it obvious.
Just to make it.
Jason,
Where'd that 1 come?
what one?
The one on top.
That?
Yeah.
Because I split them.
So, the x is just 1?
Each put that
Trying to think of a way to explain this to you, and that, can I rewrite it like this?
Yeah.
Yeah, that's what I did. All right. Glad we got past that.
Yeah.
I'm not going to show you logarithmic differentiation.
That sounds like a lot.
Hunter.
Stop questioning. What's that doing?
It's how logarithmic differentiation we used to find derivatives of stuff like this.
X to the x?
What does that mean?
Okay, so
You can't do that.
I'm not going to subject you to that yet.
Thank you.
Focus on natural logs, log base 10, or log any base, change it, and then your exponentials, okay?
So is that the stuff that's gonna be in like Calc BC?
We did that problem right there in Calc BC this morning. X to the x.
This is me. My name inside? Well, it's Steph Kid, and I'm doing this one. That's me.
Ah, that's all marked. Yes, we have homework on it.
Dang.
79.
I think we have this for the weekend.
Yep.
Wow, I didn't have it like this.
I couldn't make it already.
That was totally not traveling.
Totally not going hunting this weekend.
Totally
Right.
not getting home till Sunday.
This is what
I'm actually fine with this, I'm not doing anything.
Basic instruction statement.
Mason's like,
I'm
actually.
Yeah, it looks like a lot.
Because it is a lot.
It's no more than I usually give you. I gave you less problems here. I'm trying to get you prepped for tests. So you've got a test.
Oh my god.
It's not his fault. This is totally me. You got it. So next week we'll do 310, 311. We'll have a test the next week. Okay, so I'm trying to get your mind on product rule, quotient rule, chain rule, rates, power rule. All these are getting cycled again and again so you get practice.
Until you die.
And so when something pops up, you know what it is.
Your brain is burning.
Yeah, you don't. These simple calculations, you want to get, really, if you want to earn a 4 or higher, you need to get to the point where these just automatic. Okay, and you will. Or they're automatic, and you can get a little bit of the applications, you're earning a 3. Okay, so we'll get there. The nice thing about this is, all of third quarter, are anti-derivatives. It's the reverse of this.
Oh,
So you'll get practice going forwards and backwards all the time. You'll get
So
it
is that
down.
going from the derivative to the equation?
Yeah, that's exactly what it is.
Ah, sweet.
Okay, I'm like, so if the derivative is
Kyra.
slope of stuff with the
When?